AP Chemisters, this is Mrs. Vanderlooy bringing you the second part of section 2.6 in our notes. We were just talking about isotopes, and if you recall what an isotope is is the same element, has the same number of protons, but it has different neutrons or has a different mass number. You might also recall what a mass number is. A mass number is the sum of the protons and neutrons, and they call it a mass number because that is where the mass of the atom is located, in the nucleus. All right, so that's the mass number, your protons and your neutrons. So here is problem number 9. Somehow mine got split, so this is probably on the next page. It says that carbon has 2 naturally occurring isotopes, carbon-12 with a natural abundance of 98.93%, and, let me turn the page, carbon-13, which is a natural abundance of 1.07%. It says using the circles to represent protons, I use blue circles, you use squares, so you're probably not using colors. To represent neutrons, draw the nucleus of each isotope. How many carbon-13 atoms are present on average in a 10,000 atom sample? All right, so what's going to be in the nucleus? It's carbon. So look on your periodic table, and how many protons does each carbon have? Did you find 6? All right, so it should have had 6. If it's carbon-12, well, what's my mass number 12 minus 6 protons? Well, 12 minus 6 is 6. So your carbon-12 should have 6 protons, so I have 6 red circles, and 6 neutrons. You should have 6 squares. I'll have 6 blue ones, okay? So that would be carbon-12. Oops. Why don't you go ahead and do carbon-13. Draw it yourself, to pause this, and come back when you're done. All right, how'd you do? Well, I started off with my 6 reds and my 6 blues, but wait a minute. How many neutrons should I have? Because this is identical to carbon-12. It has 1 extra neutron, so I'll just stick that here. So I have 6 protons and I have 7 neutrons. All right, so you should have 6 circles and 7 squares. What about the second part of the question? How many carbon-13 atoms are present? Well, use this. When you see percent, usually it's percent of. Well, in math class, if you ever see the word of, you're multiplying. So what is 1.7% of 10,000? I don't know if you needed a calculator or not, but I got 107 atoms. So out of a 10,000 sample, you only have 107 carbon-13. It's stable, it exists, but you have a whole lot more carbon-12. Okay, let's talk about ions. Important for this year in chemistry. You know what an ion is, so let's check it out. Now, keep in mind, what's in the nucleus? The nucleus has your protons and neutrons. So where are my electrons? They are, circling around them in certain shells, if you will, in certain regions of space, but they're on the outside. So what's going to be more mobile are your electrons. Your protons and neutrons stay put. They're stuck in the middle. Electrons can move. Electrons can go from one to another. And so when you do gain or lose electrons, you form an ion. So a cation are often your metals, since metals lose electrons to be positive charge. I know this won't be the first time you're ever going to hear this, but maybe it helps. All right, so get ready. Lithium walks up to the bartender and says, help, help, I lost an electron. The bartender says, are you sure? Lithium says, I'm positive. Oh, that's a chemistry humor. How about another one? Beryllium walks up to that same bartender and says, help, help, I lost 2 electrons. And the bartender says, are you sure? And beryllium says, I'm positive too. Get it? Ha, ha, ha. All right, so that's your cation. So maybe you'll remember that when we're talking about, what forms positive ions. Your metals do. Your anions has an N in the word, has 2 N's in the word. They're often your non-metals because they gain electrons, become negatively charged. I don't have a bartender joke, but I have a bunch of N's for this one. So here's fluorine. It will gain an electron, become fluoride ion, a negatively charged. So now it has more electrons than protons. So think about this. Go back to my lithium. All right, how many protons does lithium have? Well, look it up in your periodic table. It has 3 protons. So how many electrons will a neutral lithium has? It has 3. What happens if it lost an electron? All right, now this lithium ion has 2 electrons, all right, because it lost 1. Okay, it still started out with 3, but it lost one to get 2. What about fluorine? Fluorine has 9 electrons. Okay, why do I know that? Because it has 9 protons. Neutral fluorine has equal numbers of protons and electrons. But now it's gained 1, so this one now has 10 electrons. There we go. And so it's gained an electron. It has 1 more electron than it has protons. So keep that in mind, okay? So we're going to fill out this chart in problem 10, okay? So here is iron. It has a mass number of 53, but what's different about problem 10 than, was it problem 8 or something? We have a charge associated with this, all right? So we can go ahead and calculate, well, how many protons does this iron have? How do I know that? I look it up in the periodic table. So iron has 26. Well, what about neutrons? I have a mass number of 53, so I have 53 particles in the nucleus. 26 of them are protons. How many of them are neutrons? Look familiar? You're subtracting again. So this is my total number of particles. And so I have 27 neutrons right here. What about electrons? A neutral iron has 26. But it's not neutral, it's positive. So what did lithium tell the bartender? Help, help, I lost an electron. So iron would go up and say, help, help, I lost 2 electrons. So if it has lost 2 electrons, well, if it started out at 26, it lost 2, how many does it have left? 24 for a net charge of 2 plus. Hey, why don't you go ahead and fill out the next one, see what you get. Pause this. All right, what did you notice? You have another iron isotope, don't you? How do I know that? Look right here, it has 26 protons. So if it's 26 protons, it must be iron. But well, how did I get my mass number? Well, I added my neutrons and my protons together to get 59. How did I know it was a +3 charge? Because over here told me. So once again, it's positive. So if it starts off at 26, it loses 3, it has 23 left. So what I'd like you to do is to really pause this and fill out the rest of the chart and see how you do. When you are all done, come back. All right, so the next one is astatine. All right, how do I know that? Because it had 85 protons. My mass number is 210. How did I get that? I added these two together. How did I know the net charge? Well, look, I have 1 extra electron than protons. It's gained an electron. How many? 1. So it's a net charge of -1. Okay, so if they are having a tug of war, if you will, the electron side is going to win out because it has 1 extra. Right. The next one is aluminum. How do I know that? Well, if you look here, I have 13 protons given aluminum. 13 plus 14 is 27, giving it the mass number. But look over here, I have fewer electrons. It lost 3 electrons, giving it a charge of +3. Over here, how do I know it's tellurium? Well, I wasn't given this, but I do know I have 54 electrons. I do know that I have 2 extra electrons. So if I have gained 2 electrons, I start out with 52. So that tells me it's tellurium, 128, because it's not 120. Yes, it is. 52 plus 76 is 128 and a -2 charge. All right, so problem number 11 says, in light of the nuclear model for the atom, which statement is true? For a given element, the size of the isotope with more neutrons is larger than the one with fewer. Or for a given element, the size of an atom is the same for all the elements isotopes. So we're talking about volume. That to me is size. I'm not talking about mass, I'm talking about volume. So which one of these is true about the volume? Well, I'm hoping you got letter B. Why is that? Because the electrons are so small compared to the rest of it that, you know, the electron cloud is what makes up the space. If you're going to talk about an ion, now we can talk about changing the size, but it doesn't say it. And for me, it looks like we're just talking about the same charge, but a different isotope. So the neutrons do not truly affect it. It's the electron cloud that affects the volume. Okay. So I'm going to quit section 2.3, or sorry, it's not section 2.3, 2.6 right here. The next blank wall will be 2.7. So don't wait to be great.